Welcome to the Hey Kings podcast, sponsored by Vermeer, your expert in forage equipment. Today on the podcast, I'm joined by Kent Thompson. Kent and his team are responsible for developing industry-leading innovations for hay and forage equipment at Vermeer Corporation in Pella, Iowa. Today, we're going to hear some of the stories about some of the largest Vermeer innovations that have come out. Things like the ZR5, the self-propelled baler that we've talked about already, the bale hawk, some of the trailed mowers. Kent and his team are the ones doing all of this innovative work, so it's really exciting to have you on today. Welcome, Kent.
Thanks for having me.
So first of all, tell us a little bit about yourself and what you do.
Sure. I guess a little background for me is I grew up on a small farm in northeast Nebraska, typical small farm, row crop, had some livestock. My dad custom baled little square bales growing up, so I guess that's where I first got into the hay business a little bit, if you want to call it that. And in high school, I started welding at a livestock panel place. There, my neighbor was maybe 6 miles away, so I do that in the summers. And it's kind of my first glimpse of, I guess, engineering, and where I guess I started really doing some fab work. That interests me a lot. You know, I'm a kind of a lifelong tinkerer, I guess, if you call it that. From there, I went to University of Nebraska-Lincoln, got my degree in ag engineering. Went to one of the majors for a little while, and then I got on with Vermeer, and I've been there about 25 years since. So hard to believe it's been that long, but throughout that, I worked on brush chippers, quad track trenchers, most of our forage product lines, but not all of them, but most of them. And then, my current role is R&D manager for Forage Innovations. So I get lucky. I get to lead a team of some talented engineers and developers and technicians. We work on some products, hopefully that are not in the market today. So it's kind of neat. We're kind of bounded by, I guess, forage related, but in a nutshell, we research some new technologies and kind of in all industries around. Doesn't matter what it is it's in, and try to find ways that we can apply it to help improve some life for some producers. So I guess in a nutshell, that's what we do. But
let's dive into some of the specific product lines that you've worked on. In the introduction, we talked about the ZR5, the bale hawk, trailed mowers, and I got a little tip about trailed mowers at an airport. Can you tell that story?
Probably not as glamorous as maybe you're thinking there, but yeah, it's a pretty simple one. It's been a while, I'll just say that too. Back when I was a project engineer for the mowers and mower conditioner team, we were in a focus group. We were trying to improve our 3-point mowers. One of the primary issues they had was hookup. If anybody's hooked up a 3-point mower, at least the old style, it wasn't that much fun. There were some smaller companies starting to develop a caddy, and got thinking, it's like, well, why don't we just build that into the mower? Literally on the way home from that event, I drew a little sketch up on a napkin, and I guess the rest is history, I guess. Pretty simple deal, but sometimes the simple ones are the best.
I would agree with that. I think if you start getting too fancy, you lose some of the beauty of a good idea, right?
That's right. Yeah, I think we kind of hit the sweet spot on that one a little bit. So
now on the podcast, we've heard about the innovations around the large round baler. We know that there was a little round baler earlier on, but really the first modern round baler was a Vermeer, right?
Yeah.
Now you've gone quite a ways past that. Can you talk about the ZR5? How did that project start? Tell us the story.
Of course, we were in our R&D role here, and I guess I've been a ZR zero-turn radius mower fan for a long time, just mowing your yard, let's say. And that's kind of got popular over the last 10, 15 years. Just sitting on that, you're just thinking, man, why can't we apply this to baling? Because it's not that different. I've been around balers a bunch and over my time at Vermeer. And so I've been a big fan of that forever. And I thought somehow we got to put those two together. So finally one day I sketched one up and presented it to the right folks. And yeah, so we ended up starting on it. Really rough, I guess I would say.
Yeah.
So one of the cool things about my team is that we're able to move quick and fast. So we literally started in, I think it was September of 15-ish, somewhere in that time frame. And then we had it driving, pull it out of the shop before Christmas that same year. So, we were able to learn really fast and quick, does this even make sense? And it kind of all started from there. And that was a super fun project because, every single day, or not every day, but every week anyway, it seemed like somebody had a new idea, with this new platform. Without the baler tractor platform, we could do so many more cool automation things that really didn't cost anything else, and we're already maybe had that sensor to do some of those things. So it was just a fun project. It was just a challenging project too, because we were trying to keep people from seeing it. So we'd move it at night and we'd tarp it, and man, we'd have people taking pictures of it out in the fields, and they did see us, and we'd politely go ask them hey, could you maybe not share that? And amazingly, all these people didn't put it out on the internet. It's so easy now to get something on the internet. So thank you to all those people that did that. It was pretty cool times, so.
Now, that's a fun story. I want to dive into something that's a little newer than even the ZR5 balers, that bale hawk. And I'm such a fan of automation. I love the idea. Now, I'm a younger generation that has played Farming Simulator. And one of the first things I did when I played Farming Simulator was went and found the mods, the modifications to the game to download, to put into the game where I could have autonomous tractors.
There you go.
And I love that. And you're doing this in real life.
Yeah.
I know there was a basis for the platform that you started with, but then can you talk through, all the sensors and the programming and just all of the things?
Oh, I can try to. What I can tell you anyway.
Yeah, of course.
Yeah. So again, obviously picking up bales, it's not the most fun thing to do after you bale the huge field with bales. So basically started out, how do we start this project, right?
Yeah.
And I'm an ag engineer, and we didn't have a ton of software guys on at that time. This is even before the ZR5 and some of that. So just started trying to figure out what we could. And Vermeer's a pretty large company, so we had some folks some were software guys, so they helped us out a little bit. In a nutshell, we really tried to figure out how to pick the best way to pick up the bale, because what we kind of found out is what you see today is certainly not the first machine we had that we thought we were going to use. Uh-huh. So it's about the third. What we found out is you really need a pretty good piece of equipment as well as software and sensors to help you out there. So, but today we use a LiDAR. We've tried some different sensors there as well, but we use that to kind of find the bale. And then we use GPS to navigate the machine to where it needs to go. And we have kind of what we call a scour pattern to kind of search the field to make sure we don't miss any bales. Once we see that bale, what we call the world map, we lock it into a location, and then we basically plot a navigation path to go pick up that bale. And then we have a series of macros. We pick up 3 bales at a total of 3 bales. So we'll pick up the first bale, second bale, third bale, and then we'll go unload it into a stack that we pre-describe on an edge of a field today, or it could be in other spots as well. But yeah, in a nutshell, that's what we do. There's a PC in it, there's software in it, but getting that smaller and smaller as we go along. But there's plenty of processing that goes on there. We have an app that we're using that notifies us when we see some objects, when it detects an object that's not a bale. The machine's smart enough right now to try to avoid that obstacle if we can. So let's just say if you or I walked up to the machine, it would try to move away from it. It'd actually slow down first if it got too close, and then try to maneuver away from you. And if you ran up to it faster, it would actually stop if it got too close. Currently, that's our test sensors that we have on there today. But then we would get a notification of that too. So let's just say a deer or something come up to the machine and stop the machine. We would get a notification, and then to go check on the machine, or potentially say, hey, no, it's just a deer and it moved away and now you can go. But so those are the type of things we're working on, trying to develop and get those finalized and tuned. But we're doing a lot of testing with that right now in these days.
Let's take a break there and we'll get a word from our sponsor.
From the hayfield to the feed bunk, look to Vermeer. You've got livestock to feed. You know about our lineup of mowers, rakes, and balers. Now, we're taking our legacy to the bunk. Introducing the Vermeer lineup of vertical mixers and feed wagons. 20 different makes and models to fit your operation. Durable, long-lasting components and accurate scales with Bluetooth capability. From the field to the feed bunk, look to Vermeer.
I took a process management course in class. This was heavy on statistics, but one of the problems, and maybe you can't talk about this, but one of the problems in this automation, and something that's super hard to do that humans are really good at, but computers are bad at, is the milkman problem, is plotting the shortest course between a whole bunch of points. And the milkman's problem is the milkman's delivery route, right? How do you plan out the most efficient route to get to those bales?
Yeah. We've had lots and lots of discussions on these.
I see. This is a question.
I don't know if I can answer that exactly. But,
okay, no trouble.
What I can say is travel time is today a significant portion. We have some algorithms in there to get us pretty close, I guess I would say. And I'll be honest, today we're more worried about making sure we pick every bale and that we're safe and those type of things versus being absolutely optimized to save every last second. Because in the end of the day, nobody's on it running. Yep. Yes, you got some fuel costs and a little bit of that, but in the end of the day, it's a pretty small amount. So time will tell. It's a prototype.
Right.
I'll just say that. So, but we're learning. We're learning a lot. I'll say that. So.
Okay, so we've talked through a couple of these innovations. Where does your process start? What inspires your team to think up these new ideas and machines?
For me, it's not like just sitting down and thinking about something. I think our team, we get out a lot. It starts by spending enough time out with producers or in the field, trying to understanding what are they looking for? What are the limitations of the current technologies, and how can we apply some of this new stuff that we've learned? I think that's kind of where it all starts for our group anyway. We collaborate a lot, discuss a lot of things. We'll take input from anybody. If anybody's got an idea or whatever, it's not like it just comes from our team either. But, I guess for me personally, at windshield time is where sometimes ideas like, maybe we did that, and, driving that way and then maybe make a quick sketch sometime. We're pretty lucky in our forage team that we have a lot of good experience. I guess I'd say of industry knowledge as well. So we can bounce ideas off of there and bring some key people in when we need to discuss through them and whatnot. So that's pretty nice. But I guess that's kind of how our process works. We kind of, if people got ideas, then we kind of brainstorm on them, and sometimes they work out and sometimes they don't. So
now you said sometimes they don't. Can you give me what did you try that didn't work?
Well, no, there's been lots of things. I'm not sure how many of them I could talk about, to be honest, because you never know. To be honest, sometimes it's maybe that sensor technology or some other thing just wasn't right, or the timing wasn't right. So we decided not to go through with it. But
sure.
I kind of mentioned like the bale hawk. If you were to see the first two machines that we thought we were going to pick up bales with, it looks a lot different than the one you see today. That is for sure. So, we certainly fail enough, but we like to say we fail fast so we can learn from it and move on, instead of wasting a bunch of time on a design that maybe isn't going to work. If we can vet that out really quick, that's a win for us, to be honest. So
I hear you telling me stories about drawing stuff out on napkins, and of course, it's much more sophisticated than that. And for the end product, right? There's a whole host of probably engineering designs and production flow designs and all sorts of things like that. But Vermeer started out of kind of a farmer innovation spirit, right?
Oh, absolutely. Yeah.
Would you say that today's Vermeer team is still motivated by that same vision?
Oh, I think so. Yeah, especially in my group, Forage Innovations. I don't want to say we're encouraged to fail, but we're not limited by. I guess we're encouraged to try things that are maybe outside of the normal. We're allowed to be. We don't really have deadlines. Let's say we have seasonal deadlines, of course, to go test things.
Right.
But in the end of the day, we want to try to make things better. We don't. My team is, not trying to get just that small incremental improvement that's absolutely needed, but we're looking for that next big thing. So yeah, like I said, we're kind of encouraged to do that, and I think Gary was a pretty free thinker on that type of stuff too, and did some pretty cool stuff. And so I think we're still encouraged today, at least in my team for sure. It's pretty fun in that regard.
Your team has the ability to think something up, go and build a prototype, and put it in the field relatively fast.
Yes.
But getting that new product on the production line and out in mass, that's way bigger, right?
That is a much bigger process, correct? To do it, in today's world, to make sure it's reliable and functions, and it's a big task for sure.
We've had some discussions on equipment designs, And in the Hay Kings world, there's a few folks that are really vocal about how equipment should be built. And generally they're farmers saying, build it a little heavier. What's the trade-offs that you struggle through as you're designing these pieces?
There's a ton of variables there that I'll miss probably half of them, but it's certainly cost versus durability versus reliability, all those things, and versus productivity, ease of use. All those things are very important, and
yes.
You try to weigh all those and develop a lot of different products out there. And to be honest, each product is a little bit different. Some pieces of equipment just need to maybe be a bit more durable and that kind of thing. And some things, I don't want to say are less expensive or just maybe not quite as heavy duty, but there's a market for some of those things too. So it's just trying to understand what does that customer really want. And, we listen in to a lot of these folks on your podcasts and the Facebook pages and that type of thing and understand, both sides of the fence there, and there's a happy balance there that we're always trying to figure out.
This is the art of design, right?
That's right.
There's not so much science to it. It's a little bit of understanding the customer and then building that product to the customer. And
it is. Yeah, it really is. And to be honest, my group has been a little bit away from that side of it. We're more worried or working on the next big thing, I guess, if you want to call it that. So we're trying to, don't get quite into those details that some folks do. And
when you're talking about shaft diameter and which bearing do you use, you just throw bearings in there and go and see if it works, right?
Yeah, a little bit. Yeah, we do. We do some calculations and that kind of thing, and some FEA. But to get to that next level, you'd start doing quite a bit more FEA and do more. We have a fantastic test facility here that we can do a lot of our hydraulics and drivetrain testing and that kind of thing. So again, we're just trying to figure out, does this concept work? Does it make sense in the market?
Yeah.
And then we make that decision after that. It's a little bit different for our group.
What I just heard you say is you're so far ahead, you're 5 years, maybe 10 years from where you start to where the finished product comes out. What's that time gap there?
Yeah. I mean, it depends on the product, crop's a tricky thing, ag and crop flow and those type of things can really make a difference. And you well know, as I know, that those conditions aren't always the same year after year after year. Sometimes that's what takes a little longer to make sure it works in all those conditions, so it can be, if it's just something, I would say, quote, quote, mechanical or hydraulic or something that's repeatable, those are a little easier to solve, most of the time, because it's just either testing or calculation or whatever. But crop flow is can be a little more challenging at times. So, usually it's somewhere between 1 and 5 years, I would say, to get through all that testing and making sure you feel good about it.
Evaluating the equipment across a range of conditions is what takes the most time in the design process.
Yeah, I would say I've worked in, like I said, the different divisions at Vermeer, and I think that's what makes forage difficult is crops change quite frequently, and you don't get a very long window to test them.
I like that was a good tidbit that I hadn't considered before, is testing in all sorts of different conditions is really what takes the time.
That's my experience anyway. It feels like anyway. So you think you're 99% there, and then you get in 1 or 2 crops, and it's like, oh, what happened?
Then you take a trip to Florida, and you realize that oh my gosh, that grass is really tall. Did we design it for this?
That's right.
Then you get into some, short cut interval alfalfa that's 6 or 9 inches tall, and it has to perform.
Or make the decision it's not going to work in both of them, and then that's a challenge in its own right. So
I appreciate your time today. This has been fantastic.
Thanks for inviting me to your show, man. Appreciate it.
Awesome. It's been wonderful having you.